So just out of curiosity, how many of you were at the session earlier today where I talked about developers and managers and whatnot? How many of the managers are still in here? Show of hands. Okay, this is all going to be about code. So you may actually, what's kind of interesting, one of the things I will often tell new speakers is when you're getting ready to do a session, you never go meta. You never talk about the session itself, but I do feel a small obligation to mention that I have not actually delivered this particular session in about 3 years. I mentioned that I kind of got into the whole management thing, right? So I think I remember how to do most of this. So if I fumble for a little bit, that's because I'm trying to remember from like 3 years ago how to actually do all of this stuff. By the way, that's me. But typically, this is the slide that people care about the least in a talk, so we'll just blow right past it. The goal of this particular presentation is to talk about all of the various hooks and various extension points that the JDK provides. And there's a whole bunch of different kinds of things that we can do, in many cases, that a lot of Java developers don't even realize is possible. So in many respects, the way that this session is designed to go is I'm going to show you a list of possibilities, and then I'm literally going to solicit questions. Essentially, can you show me how to do blah in that list? And I'll say, sure, we'll do that. Write a little bit of code. If it's short enough, some of these are going to be fairly large, like how do I compile the OpenJDK? Well, there's a really good book. Let me recommend that, and it would take hours, and so we're not going to do that here on stage. But part of the goal here is to open up the gates and to say, well, is it possible for somebody to do X, Y, or Z? Is it possible for somebody to be able to do blah? Whatever has floating around in the back of your mind somewhere. There's an equal probability that it is or it is not possible. So if you want to try to stump me, by all means, go ahead and throw that out there. The whole point of this particular session is basically to say that the JDK itself is actually an incredibly configurable environment. Sun really went to great lengths to try to make the JDK something that could fit a variety of different scenarios. And in some cases, I don't think we really don't bother using a lot of those configuration points. I think a lot of times Java developers don't even know those configuration points exist. In many respects, Sun was more interested in highlighting the latest revision of Enterprise Java Beans than they were in really discussing how runtime security policy works inside the JDK, because one sold something and the other one didn't. So part of what this session is designed to do is to make you aware of a lot of those extension points for further research and investigation later on your part, or in some cases just to be able to do various things that in some cases there are hacks and so forth that Java developers will go to that aren't really necessary if you understood what those configuration points were. Now, the JDK is also open source. The old open JDK. Well, there's actually technically two different JDKs if you want to get right down to it. And I'm not a lawyer. I mean, I'll admit to being a manager, but I will never admit to being a lawyer in any way, shape, or form. And so in some respects, if you want to take the open Java source code and you want to do something with it, technically the open Java environment is open source, and as long as you don't try to call your thing Java, and as long as you obey the issues of the license and so forth, you should be okay. So if you wanted to take the OpenJDK, for example, and redistribute it as a part of your application, technically that should be acceptable. That didn't used to be for commercial Java because Sun put very specific clauses in there that said, no, you cannot redistribute because we are Sun and we said so. OpenJDK, however, follows more of the open source model, so it's allowed to be redistributed, The important thing for us in some respects is the fact that if you looked at Java and said, wow, this platform would be so cool if, and you ever wanted to plug in your own thing, well, now it's possible. Before Java 6, you had to become a source licensee of Sun's, and you had to pay their royalties and all kinds of weirdness and madness. When Sun open sourced the JDK, it took a lot of that stuff away. But again, Oracle now owns commercial JDK, and the Oracle JDK is not quite the same as the open JDK. There are some very small differences between the two, mostly having to do with audio and video codecs. Some of them are things that Sun and then later Oracle has to pay royalties on, and so they can't include that as a part of the open source project. OpenJDK has found some acceptable alternatives. One such example, for example, TrueType fonts. Not that anybody cares about fonts anymore, but back in the day when Sun was still spinning up Java, particularly as a desktop development environment, they licensed TrueType fonts from Microsoft. Well, they can't give that away by definition, and Microsoft doesn't want to give those away because that actually turns out to be a fairly lucrative environment. So the OpenJDK makes use of FreeType, which is an open source version of TrueType. Now, don't ask me how you can have commercial and open source fonts. I don't really understand that in the slightest. But this is kind of the differences between Oracle JDK, as we now call it, and Open JDK, which is the open source equivalent. If you walked in here and heard the word hack and thought, awesome, I'm going to learn to be a black hat, I'm going to learn to crack somebody's website open and scoop out all of the really delicious innards that will allow me to retire on somebody else's bank account, please leave. Because I don't even want to know who you are. If you're just that minded, go away. I'll even turn my back so I can't see you. All right. I use the term hack here in more of the traditional Unix style, which is to say somebody who really understands the system well enough as to be able to make it do things that you might not have thought otherwise possible. And in some cases, there are a couple of features within the JDK that could actually bail you out of a late night, holy crap, stuff isn't working and I need to come up with a quick fix solution that we will, of course, refactor into something more beautiful later, right? Go like this. Yes, we promise. We promise. All right. So, speaking of lists of things, there's a number of places inside of the JDK, and I'm going to give you guys a chance to look at these. Right? When I talk about binary hacking, I'm saying I'm going to take the JDK as written, and I'm going to use it the way that Oracle or OpenJDK delivers it. The idea here, very bluntly, is we are going to do this talk in an agile fashion, which is to say we're going to iterate. You guys will look at this list, and I'll flip between the other two just to give you opportunities to look at the other two, but this is the majority of it. You're going to look at this list, and then one of you is going to feel brave enough to go, dude, and I'm going to say yes, and you're going to say, can you show me how to do blah? And I'll say, well, sure. Or I'll say, well, it's a little too cumbersome to try to do that in a session, but we'll talk about blah. And then we'll do or talk about blah, and when I'm finished, I will say, what did you think? And you'll say, that was amazing. And I'll say, you're welcome. And then we'll do that again, and we'll do that again, and we'll do that again until we run out of time. At which point, you'll fill out evals, right? Because that was amazing. And then, I don't know, I think Matt Rabel's coming here to do some bullshit after that. Okay? So, like I said, binary hack points, basically these are things that the environment provides without having to recompile the OpenJDK. And then, of course, if you have the access to the OpenJDK itself, if you have the source, you can actually do a number of very interesting things along the way. But again, this would require, in some cases, redistributing your own version of the JDK, which for a server-based environment is certainly not a difficult prospect, but certainly for a client-based environment, that would be pretty much a non-starter in many cases. So, what do you guys want to see? Let the iterations begin. Sir?
Embedding the JDK in your own native code?
Yes. So, first thing I'm going to do is we're going to end the slideshow because, slides. Who needs them? And let's see. I think I have... I guess I don't have that one specifically listed here. So one of the things that the JDK has a feature, functionality, I don't know what you want to call it. Let me bring up a browser. Wait, did I clear out my porn history? Yeah, I cleared out the porn history. All right, so here we go. JNI, how many people have heard of Java Native Interface before? Yeah, this is the thing that we were all told to stay away from because, right, pure Java meant no native code whatsoever. The Invocation Api has been a part of the JDK since version 1.1. And this is essentially the C API that sits to interface the JDK to the rest of the world. The JDK, as it turns out, is actually just a library. When you drill right down to it, the JDK is effectively a DLL, or it's a .so or a .a, depending upon your particular platform. On a Mac, it would be a .dylib. And so normally, when you write Java code, and you say Java foo, what you're running is a standardized launcher. And the source for the Java launcher has actually been published for many, many years. As a matter of fact, let me quickly do this. If you're on a Mac, they kind of tuck it away in a really weird place. They actually tuck it away out here under /library/Java, Java Virtual Machines, JDK 1.8, Contents Home, because this is kind of the way Mac just does stuff. If you're on a Windows or a Linux box, they all tend to gather it all under one directory. So under Unix, a lot of times it'll be installed in like user local Java, right? Or just user JDK in some cases. If you're on a Windows box, you often install the JDK, C prog, JDK, et cetera. But then from there, everything is drilled down in terms of the directory structure. But more importantly, as a part of a standard JDK install, this used to actually be a checkbox that you could indicate yes, no as part of the standard Java installer. And part of what they include is this source.zip file. This has actually been there since JDK 1.1, and actually I'm going to copy source.zip over to demos, projects, demos, devox, UK, so I have it over here. There it is, source.zip, and open this puppy up. All right, so inside of this guy, there's a source directory, and you can see that there's com, Java, JavaX, and org, as well as this directory called launcher. Okay? Now, com, Java, JavaX, and org, those are the roots of the standard class trees that we're familiar with, right? So all of your Java classes, for the most part, you can see Java lang. And these are all the different .java files that were a part of the JDK packages. There's probably about 93% of all of the Java classes that you will work with are a part of this source.zip. And this is not OpenJDK source per se. This stuff came from the OpenJDK source, but this comes as part of every standard install of Java. But the part that we care about is this directory called launcher here. In it, what you can see is we have a number of .c and .h files. Okay? Every time you say Java foo, you are actually running this launcher. This is not some abstracted example of, this is the actual launcher that you are running. This is what java.exe is compiled from. This is what java on a Mac or Linux looks like. And so, for example, if I come into here and fire up main, and of course, I need to set the editor font size to something more reasonable. There we go. So if we come back here, there we go, main. And make you go away. And swing you out here. As you can see, Oracle has a very long copyright notice. I asked somebody at Oracle once why exactly all of this was there, and there was some like really weird answer, like there were some tools that people were using that actually assumed that the source began at line 25 because this was the length of the Sun copyright notice, which, by the way, explicitly prevented you from using Java to run, and I'm not making this up, nuclear reactors. There was explicit proviso. If you never looked at it, go find one of the old JDK releases and look at this. It specifically says you are not allowed to use Java to run a nuclear reactor. You know what? I'm not a lawyer, but I don't see an explicit proviso Oracle's greatest fear is for people to find out that Chernobyl was actually running Java. Oh, never mind. All right, so again, right, this is main. This is main.c, and this is, we've got some if-defs, we've got some pragmas, we've got a win main here. How many Windows old C coders in the house? Yeah. Is this bringing back some bad memories? Yeah. Here's a standard main, right? Excuse me. And I won't go through all of this because that would just take bloody forever. But when we drill down through all of this stuff, drill into the JLI abstraction here, which is part of what Oracle/Sun were trying to do, is they were trying to abstract the native code aspects away in some respects to make it easier to be able to do this across multiple platforms, right? But this is some shared source for the Java command line, so you can see, for example, what splash screen should we bring up as part of launching this. And then you see this here, Java VM options. You see things like set class path, right? Initialize JVM. These are all wrappers around some of the standard JNI invocation APIs, which, taking me back to here, so JNI actually has three aspects to it. One is, how do I create a native method that can be invoked from Java? The second is, how do I write native methods that can turn around and call into Java? And the third part is the Invocation Api, which is how can I bootstrap the JVM into my running process? And fundamentally, it comes down to essentially, you say, get me a default Java virtual machine, passing in some arguments here. And then I say, create Java virtual machine. And then at that point, now it's, I want to go and find a particular class, and then I want to execute it. So let me get a hold of that static method, test, taking an integer, returning void, and then let me invoke that particular method, passing in this case, the value 100. And when you're finished, you can destroy the Java VM. Okay? Now, what exactly does this buy you? Well, for starters, there are some small cases, particularly around some of the desktop-facing Java applications. If you've ever run Eclipse, you'll notice that you don't actually say java com.ibm.subpackage1.subpackage2.subpackage3.eclipse.main, etc. Right? That's because Eclipse has basically done this. They've built a native launcher around the Java class that they want to invoke, and then they've simply embedded the name of the class and the method that they want to invoke to bootstrap the environment, which gives you a couple of things. Number one, you now have full control over the command line, because normally all of the various options that you pass in, what they do is they actually affect what's going on inside of the launcher. So if you want to specify, for example, class path to be used without relying on an external environment variable, which is wise, particularly because environment variables can change, then you can build your standard launcher here, compile and link it in the standard .c style, and now you have something that will discover the JVM running on the machine and use it. When I say discover, what I mean by that is Java, when I launch this thing, when I compile this executable, excuse me, when I compile this executable, Java needs to be where a native environment would expect it. And so, for example, if you're looking on a Windows box, there are going to be a couple of DLLs. Actually, there's going to be a number of DLLs that are going to need to be in place. And the standard process that the Windows launcher uses, for example, is to say, all right, well, the first thing I'm going to do, and we could dig into the launcher code if you really want to see it, but the first thing I'm going to do is I'm going to go look in the Windows registry, and I'm going to look under the JavaSoft key, and I'm going to dig down for a little bit until it says the current version is 1.8. Let me go look at the 1.8 key, and I will discover that Java is installed at C, program files, Java, JDK 1.8, bin. And under that will be the DLLs that I need. So we load those into the process, and then I can start going in and doing all of this. In this particular case here, without any of that, I would have to physically put the DLLs into the same directory as my executable, et cetera, et cetera, et cetera. It gives you the opportunity to construct the environment exactly the way you want it. And you'll typically do this if you're going to ship a JDK as a part of whatever it is you're installing. So normally, when I install the JDK, it's a shared Java environment that all of the various Java applications will be using collectively. But if I want to control the versioning, if I want to control the class path, create my own launcher, create my own JDK installation around it, and now I'm sort of isolated away from anybody else who wanted to screw around with whatever Java settings or install a new version of the JDK beyond 1.8. 1.9 comes out, but you're not sure your application runs on it, et cetera, et cetera, et cetera. So it gives you an opportunity to segregate yourself away from the shared JDK. Okay? So, again, you can either start with the standard Java launcher and manipulate it, right? So here, for example, is the launcher doing any sort of tracing? You can see, if you read through just the launcher code, you'll discover a couple of additional flags. In this case, it's a diagnostic flag that'll say, specifically spit out what the launcher is working on. There's a couple other ones in here, including and I forget what it was. There's an environment variable that you can specify. I think it's Java_launcher, and the launcher will tell you exactly everything it's doing as it's doing it. Right? JLI is trace launcher. This is the flag that's testing for it. Right? Where do I get the main class from, et cetera, et cetera. So again, all of this is C code, but this is all essentially an exercise in the Java native interface. So, okay. Any questions? You're good? That was me. That was. Oh, thank you. I'm glad you liked it. All right. Let's go back to slides, just so we have the list again. All right. What else would you guys like to talk about? Sir? The JVM-TI tools interface, Java Virtual Machine tools interface. So again, this is, you guys are really kind of into the whole native code. You have like a native code fetish going on here. One of the problems that we had, some of you may have come to Java somewhat later in the game, but those of us who were working with Java dating back to the Java 1.0 timeframe, we didn't have a debugger to speak of. We didn't have a profiler. We didn't really have any sort of tracing tools. We really had no idea of knowing what was going on in this big black box that was known as the JVM. They opened it up just a tiny bit with JDK 1.1. They started giving us some additional flags, like the -GC flag, so we could kind of see when garbage collections were taking place and whatnot. But if you were trying to write a profiler, if you were trying to write a debugger that would work across different flavors of Java, you were basically out of luck. You kind of had to write your own JVM and then put in the necessary hooks to get that information that you wanted. In Java 1.2, Sun introduced two native level APIs, JVM DI, the debugging interface, and JVM PI, the profiling interface. But they were never formally ratified. They were never actually considered to be a part of standard Java. They were sort of beta, kind of like Gmail is beta. It just sort of lingered in beta forever. And it was kind of frustrating because, again, if you were one of these vendors who wanted to provide a profiler environment or whatnot, then you were essentially SOL because you couldn't really build your company's product off of a beta interface. Because what happens if Sun changed it? What happens if Sun removes certain things that we absolutely need, et cetera, et cetera? So finally, in Java 5, they kind of brought DI and PI together and created the Java Virtual Machine Tools interface. And the idea here is that, again, this is all kind of native level stuff. You would essentially create what they call an agent. And an agent will typically be compiled into some form of dynamic library, a DLL on Windows or an SO file. And notice how on the Solaris operating environment, does anybody still use Solaris? Didn't that kind of die? I mean, anyway. So there's no mention of Linux or Mac because Sun kind of refused to admit that they actually existed. But the idea is that you will create some native code that can then be loaded at a predetermined point. So when you say java-agent : Sun will take your shared library, load it into the Java process, and then invoke your agent as various things occur inside of the Java environment. And essentially, this becomes an exercise in, I need to hook the appropriate place to receive the events that I'm interested in. And so here you specify agent lib. You can also put some command line options to the agent, right? And then the startup routine agent on load. And you can see that this is all specified again as JNI APIs. So again, if I don't necessarily want to spend the time building a native agent, right? Because this would be an exercise in C and, that would just take for a while. But essentially, if I create a simple native library shim, right, .c, .h, I'm sorry, a .h that includes jvmti.h, which is included as a part of the jdk/include path. That's where jni.h and jvmti.h would both be found. Then I create a method that corresponds to this signature. And by method, I mean a C function. And then this method, and it has to be this particular name, because this is what Sun's going to, or what Java's going to look for when it loads the agent. It's going to find this method, it's going to invoke it, and then this is your opportunity to register for certain kinds of events that will happen. Now, they say specifically, system properties will be set, capabilities will be available, but no bytecodes, no classes, and no objects. So this is before anything Java has been done. And so this is your opportunity. Let's see, do they have a list of the yeah. So there's a bunch of different things that we can be interested in. So for example, I want to be aware of all of the different threads that are going on inside my program. Case in point, I'm currently working with a project and we have it running in production, but it keeps, for whatever reason, dying. And I can't figure out why. I don't get good stack traces. I don't get any stack traces. It just all of a sudden quits and dies. Why? Well, one of the things I could do is I could, of course, try to convince management to let me hook up all of the machines in the cluster to debuggers, and then we'll just set breakpoints, and we'll just keep, every time the production server hits a breakpoint, we'll just make sure somebody's sitting there in front of the production server to say, no, keep going, keep going, keep going, keep going. Yeah, anytime somebody wants to attach a debugger in production, red flags go off, right? And bosses get really, really nervous. But here, I can actually write a very small scale, if you will, debugger. Create native code, load it as a part of the running production system, and periodically get a list of all the threads. I could suspend threads, interrupt it. I have complete and total control over everything thread related in here. So that if at some point I'm concerned that I'm getting deadlocks, or if I just want to drop a line into a log file every second to get a list of what the threads are, all of this is stuff that JVMTI, because it literally has perfect information about the entirety of the JVM, because it's the same thing that your debuggers use, to be very blunt. Drawback is it's native code. And native code, of course, brings with it the possibility that if you do something wrong in native code, not only will you crash your agent, you'll take the whole Java process down with it. So this is not a tool to be entered into lightly, but in some cases it can be the step before you try to convince your boss that you need to actually attach a debugger in production. Now I think, if I'm not mistaken, let's see, I thought they had an example of a simple JVMTI monitor in here, but I'm not seeing it. Oh yeah, you can also see every time memory is allocated or deallocated, right? In case you really want to kind of see what's going on in terms of your garbage collection. You can get a look at the byte codes as they're being loaded. And technically, in some respects, you could actually use some of this functionality to modify byte codes, but there's easier ways to do this if you really wanted to. Okay, so JVMTI is, whoops, what was I just looking at? Oh, okay, no, this is not what I thought it was. There it is. Yes, I agree, Oracle. Do whatever you want to do. So Oracle does have some examples of how to use JVMTI for building a simple sample. At least Sun used to have one, and I'm guessing this is it as well. But what I would suggest, if you're interested in doing this, I would start with a very simple agent that registers yourself, unregisters yourself, and then maybe just keeps track of the number of threads that are created, just to make sure that you kind of understand how all that stuff works. But again, this is very low level, very powerful, good stuff, if you like writing C code. Oh, well, thank you. Thank you. It's like you guys were told what to say. Sir, what can I do for you?
Can I see how to modify the bytecode during load?
How to modify bytecode during load. Well, you guys are really into the whole, I want to do all kinds of crazy stuff. All right.
Because it's amazing.
Because it's amazing, yes. All right, so the first thing I'm going to tell you about, there's a library out here called Cyst, which has been around for many, many years, since 1999. And Cyst is actually a library. It's not tied to what I'm about to talk about. But this is, JBoss makes use of this. This is actually a research project by a guy by the name of Shigeru Chiba from the University of Tsukuba in Japan. And it's essentially a library specifically for manipulating Java bytecode, I want to say at runtime, but from within Java, right? Because again, Java has this interesting principle of being statically typed. So once a class is defined, technically we can't really change it, although there are certain hacks that would let you.
For example, the AOP, right? Yeah, but
So AOP, depending upon whose AOP you're talking about, you could sometimes be modifying bytecode on the fly, but the original, like Gregor Cazales, when he was doing AOP, was more interested in doing it as part of the compilation time frame. Aspect J originally was just about doing aspect weaving at compile time rather than at runtime. So here, JavaSys is a library essentially designed to make it easier for you to do things like AOP. This is why JBoss uses it. They use this library to do their AOP stuff as part of the container-based interception that EJB and other environments want. But in terms of the JDK itself, and let's see, there's a package called Java Lang Instrument. Okay. Now, what this will do, again, this is another thing that would be configured at the command line. So you will create an instrumentation API. You'll create an instrumentation package in Java that makes use of these APIs. And so essentially, as part of the class loading process, if there is an instrument, if there's an instrumenter, instrumenting, whatever, if there's one of these guys loaded, then all the class loaders will eventually pass the bytecode through your instrument API in order for you to do whatever it is you want to do. And this is where JavaSys can become particularly helpful because it would allow you to do that sort of modification on the fly. I think I have a demo hiding out somewhere on my machine, but I'm not going to dig it up just because I'm a little concerned about time. But fundamentally, you're going to create an implementation of class file transformer. This is a straight up Java interface. And you can see it consists of one method, transform. Okay? Transform and roll out, Optimus Prime. Anyway, you can see it gets a class loader, the class name, the class being redefined, a protection domain, which is always tied in with the whole class loading process because of Java security rules and so forth. But then most importantly, you get a straight up byte array. And notice you hand back a byte array. What you do with this byte array in between entry and exit, totally up to you. Okay? Now, the Java Lang instrument stuff will not work for all of the classes in the JDK, right? Unlike what we were seeing earlier with JVM-TI, this will happen after Java has started to bootstrap itself. So this would not give you the opportunity to like munge with Java Lang object, okay? And that's kind of by design, because there are certain classes that Java really doesn't want you to change. Technically, security risk is what they used to say back in the day. I don't know if they still, because I mean, if you have access to the command line, security risk. But this would be your opportunity, particularly for any of your classes. And so typically the first thing you would do is you would look at the class name itself, and as long as it fits into a particular subdomain of your company's domain, because I don't know that you really want to be instrumenting Tomcat. The intent originally was that the instrument API was for profilers and like code coverage utilities and so forth, so that you can inject the necessary bits to know whether or not code was used and so forth. The original intent was not really around doing some of the aspect-oriented stuff, although they knew people would do this. And performance impact is not going to be great because this is only happening during class load time. So in some respects, what they really wanted to do with this is get people away from writing custom class loaders, because that was creating no small amount of chaos. Because now all of a sudden I've got code that wants to be AOP'd, and now I'm trying to load this inside of Tomcat, so now I have to make sure that my AOPing class loader gets somehow loaded as a part of the Tomcat class loader. It was becoming an absolute disaster. And this, I believe, shipped as part of Java 5 as well. Yeah, as part of 1.5. Okay. Once you've created your class file transformer, then you're going to create another class that will specifically get an instrumentation instance. And the instrumentation instance, as you can see, basically says, I want to add a transformer to the list. So instrumentation, which the JVM would give you, gives you an opportunity to register your transformer, and then from that point forward, all classes loaded, regardless of class loader, will come through your transformer. And you can have more than one, but it would come through your transformer, you get the opportunity to munge with the bytes, and then life moves on. Does that make sense? Yeah. Okay. And the nice thing about this is all standardized. It's a part of the core Java JDK. There's no hacks. There's no custom class loaders. You just slide this in. The only thing you also have to do is you have to specify it as a part of the Java command line as Java agent. Java agent : and you specify where the jar file is. Your transformer must be in a jar file. And as a matter of fact, your transformer, remember when I said that you get an instrumentation package? Your transformer must exhibit a pre-main. Not main, because this is happening before main, so it's pre-main. And you'll get the agent arguments that were passed, if you do -Java agent : and then any string after that gets passed in as your agent args here, in case you want to customize the transformation. But then you get that instrumentation API, and off you go. Okay? Does that make sense? Yep. Beautiful.
That was amazing.
Oh my gosh, you guys are too kind. Too kind. All right. I think I got room for one more.
Load interface implementation without a class loader.
The services API. Unfortunately, you guys are choosing the more interesting ones, which I have a hard time doing a quick demo of. So one of the things that, oops, that's not the right one. Service loader, there we go. So one of the things that Java noticed over time, and again, this actually predates Oracle's acquisition, is that we were frequently creating implementations of an interface and then wanting to load them at runtime without having to specify details, right? We wanted to be able to do this sort of factory service loader type pattern. And so as far back as, let's see, where was it? Oh, they don't say here. I believe service loader was introduced as a part of Java 6. It might have been part of 5, but I think it was part of 6. The idea is that if you have a interface that is defined somewhere, then I can actually create an implementation of that interface, bundle it into a jar file, and with a small amount of manifest entry, allow the service loader to be able to discover that service and use it without you having to do any sort of custom class loader magic whatsoever. I don't ever have to go to the class loader and say, oh, give me that one based on this interface, et cetera, et cetera. I don't have to do .new class or any of that kinds of stuff. So the idea here is that you will have a service, a class that implements a particular interface, or they say abstract class, but most of the time it was an interface, right? The provider extends this service type with this provider class here, and then that in turn can be a proxy to go load the rest of the stuff. The canonical example here is JDBC, right? I've got something that implements the driver interface, and I want to be able to load the driver and all of its related goop. So then the key thing here is that there will be a provider configuration file inside of the manifest, okay? Remember, when we take Java code and we jar it up, there is a special directory that's created inside of the jar file called meta-inf. And this is all metadata about the jar file. This is where the manifest file lives. And originally, this was intended to be where we could sign jar files cryptographically to make sure they weren't tampered with. Nobody ever actually did that, so it turned out to be kind of a waste. But we can also specify, for example, if you want to create self-executing jar files, you can put a main class entry in here indicating where the entry point is so that someone could say java-jar and just specify the jar name without having to know the actual launching class. Well, if we create a services, that is the name of a file, okay? If we create a services, I think is the name of the file. I have to go back and look here for a second. Oh, inside the directory services. Oh, yeah, and the file's name is the actual binary name of the type. So let's see, do we have an example? Yeah, here. So if in this particular case where they're talking about is I have a codec set for doing encoding and decoding. Great, so this is my service type. This is the interface. And I want to create some implementation of that. So I create the services com.example.codec set. This is the interface name, but it's actually going to be a text file that contains the implementation name. So effectively, the idea here is that when Java loads, when it sees this jar file, it's going to see the services directory inside of that, and it's going to say, oh, so for any representation, anytime somebody is looking for an implementation of ComExample codec set, then I'm going to say, I recognize ComExample impl.standard codecs. Now, presumably, the .class file and all of its related files are present in this jar. We'll just assume that for the moment. The code has to actually be there, right? But now, as someone who wants to use this codec set, you can simply say, give me a service loader of type codec set, and I want to load a codec set. If there's only one implementation, it'll load it and give it back to you. No class loaders, no .new class, no reflection, and this will give back a codec set typed instance. So that now, let's see.
Okay, but what if I want to switch implementation at runtime? I mean, I want to run with a given implementation at a certain point, and at some point I want to run a different implementation, switch to a different implementation.
So there is a way to iterate through all of the available providers of this service, right? So assuming I know that I want to, if you know that I want to switch, right, then presumably you know which types you want to switch between. So then here you could use the iterator to look at the different available providers and select one of those and load that through the load class service, load installed, right, using the extension class loader. Can't remember if this is So that's just two-string. Do they have an example? Yeah. First yields all the elements of the provider cache, lazy loads and instantiates. Yeah, so this iterator is going to give you a list of all of the different providers of this particular service, so you would be able to choose between those when instantiating. Right? And then you would just use a standard load saying, give me that particular service. Does that make sense? The service loader is going to give you the ability to iterate through all the providers, right, that are listed as, that are loaded currently.
Then I can say load and
Right.
name the one. Okay.
Right. And again, because you're doing everything based off of the service type, the interface, then you simply say, all right, well, where it used to be pointing to type A, now it's going to be pointing to type B, and people are just continuing to use through that interface. They don't know the difference.
Sure. Okay. Yes.
Does that make sense?
Amazing.
Amazing. All right. I have 5 minutes left. Does anybody want to ask a really short one?
Shall I shout?
What's that?
Is it possible, without recompiling SDK, to extend the compiler to parse the source code before the task?
Oh, to create a new Java compiler?
No, extend the existing compiler.
Kinda, sorta. It depends on what you mean by extend. It depends on what your definition of is.
Some syntactic sugar you want to add
Right.
that nobody's used before, and you want to parse to some existing Java syntax. Like a preprocessing.
Right. So there's a couple of different ways you can approach that, right? If you want to try to extend Java without rewriting the Java compiler. One, like you said, preprocessor. There have been a number of different tools in the world, including, in the very earliest days, one of the first things people did is they wrote sort of a C preprocessor for Java so that we could have hash include and whatnot, because we got to have our macros, man. Those obviously didn't last for very long, but that notion of a preprocessor, what is sometimes called a transpiler, because I'm going from source to source, certainly doable, certainly possible. The drawback is your source transpiler, your preprocessor, has to know Java unless there are very specific flags that you're looking for. So, for example, way back in the day,
That's kind of what I mean, when you sort of register things, if you see something that you don't understand.
shell out to this other thing. So there's kind of a way to do a little bit of what you're looking for. Back in the earliest days of annotations, right? The annotation committee, which I happen to be a part of, we actually talked about there is a tool that ships as a part of Java for doing annotation processing. So, for example, when you run Java, you can actually run an annotation processing tool, APT, and you could create plugins that will plug into APT. We called them apptlets. Get it? We're so funny. But the idea here was, shut up. I don't make the jokes, I just tell them. The idea here was that if, for example, you wanted to use annotations in the way, for example, xDoclet used to use documentation hints to be able to do code generation, then you could create your own annotation processing tool to recognize annotations. And so theoretically, I don't recommend this, but theoretically, you could create an applet that looks at the annotations and then emits Java source code as a part of the process. You probably would not want to change the class where the annotation lived, but again, for example, if you're JBoss and you want to generate interceptors based on an interface that this class was exposing, that would actually be a reasonable case for doing that. And then you would compile that Java code as part of a secondary step or something similar. So that kind of was giving you some of that. The only drawback, the only reason I really hesitate talking about that is because one of the fundamental precepts, which I think by now has been shot to hell, but one of the fundamental precepts of annotation is the presence or absence of an annotation shouldn't change what the compiler emits. And if you use an annotation to add some functionality to the generated code, technically you're violating that. But you wouldn't be the first. And lots of people have found some interesting and useful characteristics. And I think the latest round of annotations introduced, at nullable, at not null, etc., which pretty much changes the way the code is compiled. So, yeah, exactly. So it's by this point, I think that has become an accepted possibility that an annotation could change what the compiler produces. And so, yeah, you could use the annotation as a way of hacking in your own functionality. APT. Yeah, it should be a standard part. I haven't actually tried to run the thing in years, but it's been removed? Is it hiding in the Java compiler itself? Probably. Wouldn't surprise me. Cert. All right, well, here, let's do this. Java APT. Have been deprecated. Use the options available in the Java C tool and in annotation processing and Java. Okay, so APT went away, but the concept is still there, so I'm guessing we have to look at the right flag for Java C. So, yeah. If you're still using 7, it looks like it's still there. But if you're on 8 already, then, well, that was circular. Anyway, we can look at it later if you can't figure it out or find it or whatnot. Okay. And I have officially less than 60 seconds, and so I'm going to do something totally undocumented in my history as a speaker. I'm going to let you guys go early. Bye.